Okay, so I'm going to go over the answers to the test we just had with significant figures. Uh, significant figures can get kind of confusing. The more you use them, the better you'll get at them. I want to go over this test particular so that we can kind of reinforce sig figs and scientific notation. So the first question says, I have this number here, 104,000. How many sig figs does it have? Well, we don't know the scale, so we're not sure if these zeros are real or not. So what we got to do is assume that these zeros are just placeholders. That means these three numbers here are the only ones that are significant. So this answer has three significant figures. Okay. Now, if there was a decimal here, then we'd count all six. Or if we knew the scale and we knew that this went to the ones, the scale went to the ones, we'd know it'd be all six. But that's it. All right. Which number below does not have three sig figs? Okay, A has three sig figs. Okay. What we're assuming is that this is either, if you're not given an operation, okay, multiplication, division, addition, or subtraction, you use the number sig figs is like multiplication and division. You count all the numbers, okay, the non-zero numbers. All right, so these two are leading zeros, so they don't count. Now, if it was addition and subtraction, this one that would actually would, but so we only have 3.07, so there's three digits here, so this one's fine. Okay, the second one, well, it's exactly the same, so that's fine. The third one, that's fine as well. Any zero after a decimal point, okay, counts as long as it's not leading. Okay, so this zero counts. So this one has three sig figs. All right. Okay, this one only has two because this zero we don't know what kind of scale it comes from, so we don't let it. So this is our answer right here. Okay. The last one has three sig figs. Okay. When you count sig figs in scientific notations, it's always the leading numbers that count for a sig fig. All right, convert the number or this number to proper scientific notation. Okay, so the way that I like to do this is I like to change this here to scientific notation. So it'd be 7.8 .80 times 10 to the, so I know the exponent is going to be negative because it's less than 0. And how many zeros they have to go over? 1, 2, 3, 4. So this is going to be -4. Okay, and then include the 10 to the -8. Okay, and then I combine my two exponents, so I get 7.80 times 10 to the 12. Okay, which is right here. All right. Now, I don't know. Some people go to the right, it's negative; to the left, it's positive, moving the decimal point. What I do, I just try to make sense. I know that this is a negative exponent, so I put the negative there first, and then I count to zeros. Okay. So 1, 2, 3, 4. Now, if you had, like this, 78,000. Okay, so I know in this case, I know if I want to change the scientific notation, I know that this would be a positive number because it's greater than 0. Okay, and greater than 1 actually, and so it's gonna. So I go 1, 2, 3, 4, and so this is positive 4 or 7.8 times 10 to the 4th. Okay. So when you do these, I would suggest figure out if it's negative or positive exponent by just looking at the number. Okay. If it's less than 1, then it's got to be a negative, and if it's greater than 1, it has to be positive. And then you just move over to decimal points, and that'll be either way, right or left, and that'll be your exponents. Okay, and remember, when you multiply exponents, you add the exponents. All right, so this one's similar to the last problem. So the first thing I do is I take this guy and I change that to exponent form. Okay, so I know this is going to be 1.20. Okay, that's because this 0 counts. All right, it counts because it's there. Now if it was 1200 and no decimal points, or 120, then you wouldn't count to 0. But zeros after numbers, after decimal points, count. All right, so this could be 1.2. It's going to be a negative exponent because I know it's less than 1. And it's 1, 2 over, so it's negative 2. Okay, and then I include 10 to the minus 4th. And then I get 1.20 times 10 to the second. Okay, right, you can see none of these guys give that number. Okay, but this number here is the same as this number because it's in standard form. Okay, so I want to change this to standard form, so it's 120.0. This 0 counts, so you're going to put a decimal point there. Okay, if it didn't count, okay, like if you just had 1.2 times 10 to the second and wanted standard form, it'd just be a 120. Okay. Okay, use proper scientific notation. How would you round this number here? Okay, first of all, so I want to get this, so I only want to have 2 digits, so I can only have this digit, and so I can only have 2 digits, okay? So when you look at this number here, this number rounds to 10, okay? All right, now not 1 0, but it actually rounds to 10. Okay, so because it's 8, rounds this to 0, and then that rounds this to 10. Okay, so you just can't write 10 because then you lose this. All right, so what you're saying is that this number is not 9.9 or 11. Okay. So actually, so yeah, so you have to include this decimal point here. Okay, all right, so that's the first thing. I'm not done. Okay, I had to round this first of all up to 10. Okay, all right, 9.98 rounds up to 10, and that's a real 0 there. Okay, so now I have this right now. Okay, now I have to change 10 to a scientific notation. So we got 10 times 10 to the first. Then I combine the two, 10 to the first times 10 to the minus fifth. I get 1.0 times 10 to the fourth. Okay. Now this it's a little tricky, but you just can't lose this 0 here. Okay. So that's the hard part about this one. Okay, so all right, okay. Okay, so I want to multiply and divide these. Okay, well, so the first thing I'm doing is figure out the number of sig figs, and then do the math, and then combine those two operations. Now you could do the opposite. You could do the math first and then the sig figs. So number of sig figs, since I'm doing multiplication and division, you count all the numbers if they're not leading zeros. Okay, so this has 4 significant digits. This last 0 counts. Okay, it's only if it's a non-decimal point like that these zeros don't count. All right, and these zeros don't count if you don't have a decimal point. All right, now this one only has 1 sig fig because the leading zeros don't count. So my answer can only have 1 sig fig. Right. So it's just going to take practice, okay? And so zeros count, and sometimes they don't. All right. Okay. So my aunt's going to only have one sig fig. Well, I'm going to do the math without thinking, without worrying about sig figs. Okay. Say take this divided by this, and I get this number here, and actually goes on forever. Okay. All right. And so you're not going to write 898.8 3/8 with a bar over it, 8 repeating. Okay. What we want to do is have sig figs. Okay. We're only allowed to have one sig figs, and it's to the hundredths. Okay. So this is going to round up to 900. Okay. So we have 900. Okay. This is the only number that counts in terms of sig figs, but we just can't write down 9. We have to have the 2 zeros to tell me it's that's in the hundreds. Okay. Now when we look at the answers, okay, this one doesn't round. So you might get to these, like these 3 answers here. Right. You can't have this number here because even though the 9 is the only significant digit, if you leave off the zeros, this no longer tells you you're in the hundreds. Okay. This value actually tells you that you would have 2 significant digits, and then you would actually know this number and this number here. Okay. Right. And we don't. We're only sure of this number here. We're only allowed to have one sig fig. So this has 2 sig. This answer only has 1 sig fig. This 9 here, and these 2 are don't count. It's the placeholders. If you have questions about this, make sure you ask me. All right. This is one reason I'm going over this. So if you see one of these problems, go, can you go back over that and let me know? I'll write you, and that can help. Maybe hopefully I'll give you more of an explanation how it works. Okay. Okay, which of the distance are longest? So what I did is I converted them all to meters. All right. Okay. And so I had to know the conversions. I knew that this is micrometer, and I knew there was 1,000,000 micrometers per meter. And if you don't know this, you can look it up. But some things you probably should remember, that milli means 10 to the third minus third. Okay, this is symbolized as a little m. Micro, okay, is 10 to the minus 6. Okay, nano is little n. Nano is 10 to the minus 9. And, okay, pico, if we had it, would be 10 to the minus 12. All right. And then going in the bigger division, bigger way, kilometer, or kilo I mean, okay, small k, would be 10 to the third, and mega would be big M. To the 6, and there's more as well, like after mega there's giga and so forth. Okay, so all right, so this is the way I did. So each one of them I figured out their meters, converted them all to meters, and so I knew there was 1,000 meters per kilometer. I knew that there was there should be nanometers here. So there's 1 meter is 10 to the 9th nanometers. There's a 10 to the 2nd centimeters per meter, and 10 to the 3rd millimeters per meter. And when you do this, you get, as I set them up so the kilometers cancel out, the nanometers cancel out, centimeters cancel out, and millimeters cancel out. And remember, since this is 10 to the 9th on the bottom, you can change that to 10 to the minus 9th. So that's why these have negatives. So this could be So this is 10 to the minus 6. 1 over 10 to the 6 is the same thing as 10 to the minus 6. And that's why I got those. And then again, add the exponents. You get 10 to the 4th, 10 to the 1st, 10 to the 5th, minus 5th, 10 to the 1st, negative 1st. And this is 10 to the 0. Okay, so remember, anything to 0 power is 1. All right. And so this number is the biggest. All right, next problem. I want to change micrograms to grams, so I have to know the conversion. I know there's 1,000,000 micrograms per gram. So I have this relationship here. 1 gram is 10 to the 6 micrograms. Right, so the micrograms cancel out, so I end up with grams. Add your exponents, 10 to 1 over 10 to the 6, same thing, 10 to the minus 6. And so you get 10 to the minus 4th. Okay, ordered 10 to the minus 7th in millimeters, kiloseconds to milliseconds. Okay, so the way I'm going to do this is I don't know the direct conversion to these from kiloseconds to milliseconds, so but I know a relationship from kiloseconds to seconds and milliseconds to seconds. So first of all, I'm going to change this guy to seconds, and then down to milliseconds. So the kilo means 1,000, so there's 1,000 seconds per kiloseconds. Set up so the kiloseconds cancel out, and I know there's 1,000 milliseconds per second, and the seconds cancel out, so I end up with milliseconds. Right, so I have 10 to the minus 7th and 10 to the 6th, 10 to the 3rd times 10 to the 3rd, 10 to the 6th. Add your exponents, you get this. And this doesn't enter any of the answers, but there is one in standard, and that's your right there. Okay. This has 1 sig fig, and so does this. All right, so I notice people seem to get this one wrong, and it could be that you didn't do this operation here. So what I want to do, I know that there's 12 inches per foot, okay, but the problem is that if you have to square, it says inches squared per feet squared, so you have to multiply, so you have to square the 12 as 2 as well. So it's 125 feet squared, so the feet squared cancel out, and then 12 squared, okay? So don't forget to do that. I mean, I remember doing that mistake all the time. So it's 125 times 144, which is 18,000. Okay, we're allowed to have 3 sig figs, so we can go 1, 2, 3, so we're allowed to go to this 0 here. So, so you could write 18, 0, and then these 2 are placeholders. And then scientific notation would have it as 1.0 times 10 to the 4th, and there you go. Okay, so this one's a little. This one you have to do some conversions, and again you got to be careful about your cubics. Your cubes, all right? So we want to go to cubic centimeters per nanosecond. So you got to do two conversions, and actually I'm gonna do more than 2. So the first thing I'm gonna do is I have feet, so I'm gonna try to get feet to centimeters. Okay, I know that feet, I can get feet to inches, and then inches to centimeters. That should be to the 9th power. And so, all right, so I'm going to cube the 12. Okay, it's 12 inches cubed, so it's cube that 12, so that's 1728. And then I got to so the feet cubed will cancel out. And then inches cubed will cancel out if I cubed 2.54, and that's that value. Okay, and then I have 10 to the minus 9th over here. Okay, and because I have there are 1 second is 10 to the 9th nanoseconds, which is the same thing as 10 to the 9th seconds. Okay, my units work out. All right, so now I have these numbers here. I have this number here, so I converted this to this. I have this number, and this number. So now I'm going to just do the math of the 8.5, this number, and they come up with this number here. Okay, so I'm not going to worry about this number yet. I'm going to get just worried about my numbers. Okay, now I want to get Sig Figs. I'm allowed to have 2 Sig Figs, 85. So I can only have 2 and 4. Okay, so that's going to be 2, 4. So this is going to be 2.4 times 10 to the 5th. All right, now I got to combine my 10 to the 4th. Okay, because all I did was multiply the 8.5, this, and this. I didn't add this to it. So now I have this value, which is 8.5, 1728, 16,387. That comes up with this. And then I have to include the exponents, 10 to the 4th, 10 to the 5th, this value here, and then 10 to the minus 9th, this value here. And then these end up being 10 to the 9th, which sort of cancel out with this guy to give you just 2.4. So your answer is 2.4 centimeters cubed per nanosecond. Okay, so this problem, you have an area, you multiply the two numbers and you get this number here, but you're only allowed to have 2 Sig Figs, so you can only have these two numbers here. Well, this 9 rounds this guy up to 18. Okay, and there's your answer right there. Okay, now this is addition. Okay, for addition, it's a different ways. It's a different with Sig Figs. You count the number of digits right at a decimal point. So this number here has 1, 2, 3, 4, 5 Sig Figs. Okay, I mean this. Whoops, my bad. I meant this number here, 6.079. That has 3 Sig Figs. Okay, so this has 3 Sig Figs. This has 1, 2, 3, 4, 5. And yep, this 0 counts. Okay, that's the weird thing about addition and subtraction, is that decimals zeros after the decimal point, even if they're leading, they count. Right. And then this guy has 2. 2 digits here. Remember, you're counting digits right of the number. All right. Okay. Okay. So that's the big thing different about addition and subtraction. Leading zeros count after the decimal point. Okay, so our answer can only have 2 digits. Right, so I go ahead and do the math, and I come up with this, and I only can have 2 digits right of the decimal point. That's what that means. Okay, and it doesn't mean overall. Okay, so if it's multiply, and I said multiplication and division, you would say it's 9.1. For subtraction and addition, it's how many digits are right at the decimal point. Well, this 6 rounds this guy up to 6, so this is 9.16. Okay. Okay, the next problem, it says I want to do scientific notation for 550 decimal point ml. So first thing I'm going to do is I'm going to change this to scientific notation. So it's 5.50 times 10 to the second milliliters. Okay, so this tells me I have 3 Sig Figs, and this is 3 figs right here. All right, the conversion to liters to milliliters is 1,000 mils per liter. These conversions, okay, are exact. So whenever you have an exact conversion, you don't count their Sig Figs. In a previous example, you had 2.54 centimeters equals 1 inch. Okay, well, these days actually this is a exact measurement, but sometimes there isn't exact measurements. For instance, I have a better example. Let's say 3.785 liters per 1 gallon. Okay, this is inexact relationship. So we would have to count this Sig Figs as 4. All right. So whenever we have exact, and you would have to be told that, all right? Whenever we do molar masses and densities, any empirical values we have to measure conversions, they are inexact, and you have to count their Sig Figs. But when they're exact, I know they're exactly 1,000 mils per liter. You don't have to worry about the Sig Figs. The only Sig Figs you have to worry about are the ones here. All right. Okay. So so this is the same thing as. So the mils cancel out, and you end up with liters. The same thing as 10 to the minus third. Okay, this is 1 over 10 to the third, 1 over 10 to the third, which is the same thing as 10 to the minus third. You add the exponents, you get this, and follow 5.50 times 10 to the minus first liters. Okay, density problem. Okay, now this is an inexact conversion or relationship. So now, so we would have to count this Sig Figs. So this has 3 Sig Figs, and this does, and so our answer has 3 Sig Figs. Okay, so we just set it up, 3.32 grams. We want to turn this upside down so that the grams cancel out, and then you just do the math, and you get 1.2296 centimeters cubed. We're allowed to have 3 Sig Figs, 1, 2, 3, the 9 rounds to 2 up to 3, and so there's your answer. Okay, how many grams are 1 kilogram? This is the exact relationship. There are 1,000 grams per kilogram. So you could, I mean, you don't have to do this if you know it, but it's exactly 1,000. Now, really, I mean, this should be, 1,000. It's exactly 1,000, right? It's not, these 3 zeros are all there actually, okay? But if you just looked at this as 1,000, you would go, there's only 1 Sig Fig. But no, this is an exact relationship, okay? And this is the kind of thing about Sig Figs and numbers and all that. You have to think about the numbers that you have, where they come from. I mean, if I just wrote down 1,000, like I said, in the PowerPoint, this 1,000 could be all kinds of things, okay? As far as it's significant. But since you don't know what scale it comes from, you would say it only has 1 Sig Fig. So in this case, you know the scale that it comes from, that there's 1,000 grams per kilogram, and so these are all 1,000, or 10 to the third. And we'll go over this again and again during the class. So if you don't get it right now, we will keep on, trying to reinforce these things. And you, again, got questions, ask. All right, how many nanoliters are in 15.7 milliliters? So what I'm going to do is I don't know this direct relationship. So what I'm going to do is change liters to milliliters to liters and liters and nanoliters. Okay, so I know this relationship right here. There's 1,000 mils per liter, and so the mils cancel out. All right, so put this conversion factor so the mils cancel out. There are 10 to the 9th nanometers per liter, and then the liters will cancel out. And then you have 1 over 10 to the third, which is 10 to the minus third, and times 10 to the 9th. And then add your exponents, and okay, and you get 15.7 10 to 6 nanoliters. I got to change this to scientific notation, which is this right here. Right, 1.7 times 10 to the first times 10 to the 6th. I get 1.7 times 10 to the 7th. Okay, megameters to centimeters. Again, what I'm going to do is change this to meters and this to megameters. Okay, so I'm going to change this first to actually scientific notation. So 4.65 times 10 to the second centimeters. I'll do the conversion, and now I'm left with meters. Okay, I know there's 10 to 6 meters per megameter. Now the meters will cancel out. I have megameters now. All right, now I have 4.65. This is 10 to the minus second, and this is 10 to the minus 6. And so this is your answer. Okay. So I know 1 meter is equal to 10 to the second centimeters. Okay, and you could write the conversion factor is 1 meter over 10 to the second centimeters, or 10 to the second centimeters over 1 meter. You picked the right one to cancel out the centimeters, so I'm going to pick this one right here, and that's why I picked it right there. Okay, same thing with this. I wanted to cancel out the meters, so I knew the relation of 1 megameter is equal to 10 to the 6 meters, and then I set this up so the meters cancel out here and here, and I'm left with megameters. Appropriate units. Okay, this is distance. Okay, this is a distance, but it's really tiny. You could do it, but it's kind of inappropriate. This measures mass. This is distance, but it's better because this is probably long distance. Now, if it was only an inch long, maybe millimeters would be okay. This is volume. So this is the one that makes best sense. Which one would measure the volume? Okay. This measures volume, so that's probably a good choice. It's temperature, length, and grams, mass. So A is your definite choice. Okay. In addition to subtraction, the significant figures in the answer must reflect. Okay. The number in the calculation with the few significant figures. Yes, but we have to be more clear, maybe. So we'll put. Okay, so maybe, but is there a better answer? Number in the calculation with most significant figures? No, you can't have that. Average? No, you can't have that. Right, now, least precise measurement, okay, that's kind of like this one here. All right, and it tells me actually how to calculate that. Least number of decimal places, okay, so it's D, okay. So this one looks like it could be the answer, but this one is a better answer. Okay, division multiplication. The answer must have more significant digits than figures than number in the calculation with the fewest significant. Yes. Okay, see, let's see if there's a better answer. Number in the calculation with no, and no. Okay, because significant Multiplication, you count all the digits, so it's going to be A. All right, how many seconds are in a day? Okay, so 24 hours per day, days cancel out, 60 minutes per hour, minutes cancel out, do the math, get this number here. It doesn't ask for Sig Figs or scientific notation, so this is your best answer. Okay, number Sig Figs here. Okay, since we don't know if it's multiplication or addition, you assume it's going to be multiplication and division. If it was addition, you would count this 0 here. It'd be 1, 2, 3, 4, 5, 6. Okay, but if you just see the numbers all by themselves, you use the same rule as multiplication division. So this one, leading zeros don't count. So 1, 2, 3, 4, 5. Right. Okay, how many significant digits does this have? Okay, there's no decimal points, so ending zeros don't count. So we only have 2. Okay, the relationship between mass, material, and volume. Okay, hopefully you guys know this. Mass per volume. If some measurements agree closely to each other but not the actual value, these measurements are precise but not accurate. Okay, because they're close to each other. They're precise, but they're not the actual value. All right. Okay. So closely means they're precise, and the only so it's either A or D, and it's not near the actual value. Not the actual value, so it's not D. In order, largest, smallest. Okay, well, you just have to work through it. Kilometers are bigger than everything else, then meters, centimeters, millimeters, so B. Okay, this number rounded 3 digits. This 5 is going to round up to 7, so it's going to be 1.68. All right, X-rays, 300,000 meters per second. Okay, this decimal tells me that all these zeros count. So, so there's so it's going to be 3.00. All the zeros count. 3. So there's 5 zeros. 1, 2, 3, 4, 5. And we're 10 to the 5th. All right, and the last problem. The last problem that I ask you to do. All right, so you're given that 1 mole of gold is 196.9655. This is an inexact ratio, so you have to count the Sig Figs. So there are 7 Sig Figs here. Okay, unless you're adding and subtracting, then it'd be 4. Okay, this is an inexact number 2, so this has 4. This is an inexact number as well, so it's 3. And again, this is an inexact number, so this has 4 Sig Figs. So your answer will only have 3 Sig Figs. So I'm going to change this value here and this value to Sig Figs. So 202.5 is this, 10 to the second, and this. All right. All right. Okay, so first thing I'm going to do is I want to get grams. So I want to end up, so what I'm going to do is I'm going to go from grams to moles to atoms, okay, to meters to kilometers. Okay, all right. And so I have 2.025 10 to the second grams. I want to get rid of the grams. Right, now I have moles. Okay, so I'm going to use this conversion here. I'm going to use 6.022 times 10 to the 23rd over 1 mole, so the moles cancel out. And then I know there's 3.58 times 10 to the minus 10th meters per atom. So the atoms cancel out. And I know there are 10 to the third meters per kilometer. The meters cancel out, and I end up with kilometers. Okay. All right, so now what I do is I'm going to separate the exponents from the real numbers. So I get there should be a 2.025 here times 6.02 times 3.58 divided by 1.696. So I'm not going to do anything with Sig Figs yet. Just do the dirty math, okay? Don't worry about Sig Figs until you're done. We know that we only allowed 3. All right, so I multiply all these numbers together here, and then I get so I end up getting 22.164, and then I take care of the exponents. I get 10 to the second, which is right here. I get 10 to the 23rd, which is right here. I get 10 to the minus 10th, right there. Get 10 to the minus 2 here, because it's on the bottom. And I get 10 to the minus 3rd here, right here. All right. Okay. So I got these guys here. Now, these are the ones where you have to worry about Sig Figs. So I'm going to change it. So this can only be 22.2. So this number, so the exponents, you don't worry about the Sig Figs. So you're going to have 22.2, which converts x to scientific notation as 2.22 times 10 to the first. Okay, and then what I'm going to do is I'm going to add all this. I'm going to add this with my exponents, and then I get 10 to the 11th. Okay, so I have 10 to the second, 10 to the 23rd, 10 to the 10th, 10 minus 10, 10 to the minus second, 10 to the minus third, and then 10 to the minus first. When you add all the exponents up, they come out 10 to the 11th. So my answer is 2.22 times 10 to the 11th kilometers. And there you go. Okay, so you might want to keep this one around to help you study help you with Sig Figs in the future. Again, if you have and scientific notation and conversions, and if you have questions about this, let me know. It's I don't expect you to be experts at this right now. It's going to take practice and use. All right. Okay.